Alright, this video is about solving an inequality and graphing an inequality. So we've talked previously about how to write inequalities from words, how to graph an inequality, a simple inequality like something like x is less than or equal to 4. Now we're going to talk about how do you take an inequality that has solving and graph that. So when we solve inequalities, the first thing we want to do is get our variable alone, because we cannot graph anything until it looks something like x is, or a variable is, less than, equal to, greater than a number. So we're looking for something like x is less than or equal to 7, or a variable is an inequality sign and then a number. So the first thing I need to do is solve. So I'm going to rewrite this down here. Let's write our first step. First step is to solve. So I have 20 plus n is less than or equal to 17. Just like when we solve an equation, I'm going to draw a line down my equal sign. Now my goal is still to isolate the variable. So I'm going to ask myself, okay, what's happening to n? How do I get n alone? Well, I notice that right now I'm adding 20 to n, and in order to do that, I need to subtract 20. To undo plus positive 20, I'm going to minus 20. Anything I do to this side, I have to do to the other side, so I'm going to minus 20. This cancels out. I'm left with n, bring down my inequality sign, less than or equal to, and 17 minus 20 is negative 3. So my inequality is actually that n is less than or equal to negative 3. Now, in order to graph that, I know I need to use a closed dot. So I'm going to put a closed dot on a negative 3. I'm going to pick my two test points. So I'm going to pick negative 1. And I'll pick negative 5. So is negative 1 less than or equal to negative 3? That is false. Negative 1 is actually bigger than negative 3. Is negative 5 less than or equal to negative 3? Yes, that works. So I'm going to shade to my left. Alright, let's do another example. Let's take something like 30 is greater than x plus 20. So I'm going to go ahead and rewrite my equation down here. 30 is greater than x plus 20. Now, we didn't finish up our steps on the other page. Remember, our first step was to solve. And then secondly, after we've solved, we're going to graph. So, first thing I want to do is solve. So I'm going to put a line down my equal sign, just like I would do normally. I'm going to bring down my 30, and I'm going to say, okay, how do I undo x plus 20? Or how do I undo plus 20? I'm going to minus 20 from both sides. I don't want to bring down my 30. I'm going to minus 20 from both sides. So I'm going to cancel out my 20 minus 20. 30 minus 20 is 10, and I still have is less than, and I'm going to bring down my x. Now right now I have that 10 is less than x. We've talked about in previous videos that what we want to do is make it so that the x is on the left hand side. So I'm going to rewrite this as x is greater than 10. X is greater than 10. So I'm going to go on my number line, and I'm going to draw an open circle because this is a greater than symbol. And I'm going to pick two test points. I'm going to pick 12 and 9. Let's see which one works. Is 12 greater than 10? Yes. Is 9 greater than 10? No. So that means I need to graph to the right. Let's do another example. Let's take this one. A divided by 13 is less than or equal to, greater than or equal to 18. So I have A over 13 is greater than or equal to 18. Alright, now I'm going to ask myself, how do I get A alone? What's happening to A? Well, draw my line down the middle. Right now this says A divided by 13. How do I undo divide by 13? I multiply both sides by 13. These cancel out. I'm going to bring down my A, and I have as greater than or equal to 18 times 13 is 234. So my variables on the left, so I'm going to write it up here. A is greater than or equal to 234. I know I want to put a closed dot because it has an equal to, so I'm going to put a closed dot, 234. And I'm going to pick my two test points. I'm going to pick 236 and 232. So is 236 greater than or equal to 234? Yes, 236 is greater than 234. Is 232 less than or equal to 234? I'm sorry, I wrote my inequality sign backwards. We need to write a greater than. Remember that you want your inequality sign to be the same one here. So 232, my number on the left, is that greater than 234? No. 232 is less than 234. So that tells me that I need to shade towards the 236. And I'm going to go ahead and shade that way. Alright, we're going to do a couple more examples, and these are going to get slightly more tricky, so it's really important that you're paying attention as to why we're doing what we're doing. Okay. Let's take this example. Negative 2 is less than or equal to x over 4. Negative 2 is less than or equal to x over 4. So, I'm going to say, okay, what's happening to x? Right now, x is being divided by 4. How do I undo divide by 4? I multiply by 4. 4 times negative 2 is negative 8. And I have less than or equal to, these 4's cancel out, x. Now, we're going to talk about in a second some things that can happen when you are multiplying or dividing by negatives. But notice here that we are multiplying by a positive number. In order to graph this, I need to rearrange it so that the x is on the left. So I'm going to rearrange this as x is greater than or equal to negative 8. I know I need a closed dot at negative 8. And I'm going to pick two test points. I'm going to pick negative 6 and negative 10. Is negative 6 greater than or equal to negative 8? Or is negative 6 greater than or equal to, or is negative 10 greater than or equal to negative 8? Alright, is negative 6 greater than or equal to negative 8? Yes. Remember, the bigger the negative number, the smaller it actually is. Think about that temperature example. Would you rather it be negative 6 degrees or negative 8 degrees? Probably negative 6. That's a little bit warmer. So negative 6 is greater than or equal to negative 8. Negative 10 is not greater than or equal to negative 8. So that tells me that we need to shade to the right. Okay. Let's take this example. We have negative 19x is greater than negative 304. Now, there's a rule that we need to talk about at this point. And here is the rule. When you multiply or divide by a negative. When you multiply or divide by a negative, the key word here is by, and we'll talk about it in a second. When you multiply or divide by a negative, when solving an inequality, you flip the inequality symbol. When you multiply or divide by a negative when solving an inequality, you flip the inequality symbol. So up here, I'm going to give you two examples, and somewhere on your paper I want you to do that. Now let's say you had something like 3x is less than or equal to negative 6. Now I know that I need to divide both sides by 3 to get x alone. So I'm going to divide both sides by 3. This is not a negative. I am not dividing by a negative. I am merely dividing by a positive 3. These 3's cancel out, and I'm left with x is less than or equal to negative 2. Now let's talk about an example where you would be multiplying or dividing by a negative. Let's say I had negative 3 is less than or equal, negative 3x, let's rewrite that. Let's say we had negative 3x is less than or equal to negative 6. Now this is different because my coefficient on the x is a negative 3. So to undo x, I need to divide by, the key word there is by, negative 3. When you are dividing by a negative, the number that you are crossing out is a negative. You flip the sign. So this becomes x is, and instead of a less than or equal to, I'm going to put greater than or equal to positive 2. There's two examples. Let's do an example like this. I have negative 19x is greater than negative 304. So let's talk about what we would do. First thing I need to figure out is how do I get x alone? Well, between negative 19 and x is multiplication, and to undo multiplication I need to divide. So I need to divide this side by a negative 19. Notice I said I'm dividing by a negative, dividing by a negative. Because I'm dividing by a negative, I need to flip my inequality at the end. So what that's going to look like is these cancel out. I'm left with x is, since I divided by a negative, I'm going to have x is less than, and negative 304 divided by negative 19 is a positive 16. So my inequality is actually x is less than 16. When you are dividing by a negative, it flips. If this number happens to be positive or this number happens to be negative, it does not matter. You only flip it if you are dividing by a negative. So let's go ahead and graph this. I'm going to do an open circle since it is a less than symbol. I know that it needs to be less than. I'm going to pick 2 test points. We'll do that up here. Say the first test point I'm going to pick is 14. And the second test point I'm going to pick is 17. So is 14 less than 16? Yes. Is 17 less than 16? No. So I'm going to graph to my left. Remember to make your lines thick. Let's do a couple more examples, especially when we have to deal with dividing or multiplying by something. Alright, let's try this one. I got negative 98 is less than 7k. Alright, so I got to get k alone. How do I get k alone? Well, right now it's saying 7 times k is greater than negative 98. So to undo 7 times k, I need to divide. So I'm going to divide both sides by positive 7. Now notice in this example, I'm dividing by a positive number. I am not dividing by a negative. We only flip the sign. Look back at your rule. We only flip the sign when we're dividing or multiplying by a negative. This is a positive number we are dividing by. It is okay that this is negative. Because of that, these 7's cancel. My inequality sign is going to stay the same. It does not flip. It only flips if we are dividing or multiplying by a negative, and these are both positive numbers. Now I can finish out the other side. A negative 98 divided by positive 7 is a negative 14. In order to graph this, I need my k to be first. I'm going to rewrite this as k is greater than negative 14. I need an open circle. That's 14. I'm going to pick two test points to decide which way to graph. First, I'm going to pick negative 12, and I'll also pick negative 16. So is negative 12 greater than negative 14, or is negative 16 greater than negative 14? All right, is negative 12 greater than negative 14? Yes. Oh, I wrote this one wrong. Or, that was our first one. Or is negative 16 greater than negative 14? Well, actually, negative 16 is smaller than negative 14, so this one does not work. So I need to graph to the right. All right, now let's try an example that's a little more complicated. We have n over 15 plus 7 is greater than 6. Now remember, your first step is always to just solve. You need to get your variable by itself. This is a two-step equation. You can solve a two-step equation. Remember, using reverse PEMDAS. We want to use reverse PEMDAS. The first thing we want to get rid of is any addition or subtraction. So the first thing I should get rid of is plus 7. How do I undo plus 7? I minus 7. Now, a common mistake a lot of students make is they see, oh, this is a minus 7, which is like a negative 7, so I need to flip this sign. No. The only time you flip the sign is if you are multiplying or dividing by a negative. This is just a minus. So these cancel. I'm left with n over 15 is greater than 6 minus 7 is negative 1. Now, I still need to get n alone. How do I undo n divided by 15? I multiply by 15. I am multiplying by a positive number, so my sign is not going to flip. So I'm left with n is greater than negative 1 times 15 is negative 15. Go ahead and try to graph that one on your own. N is greater than negative 15. You should have had an open circle at 15. Which is right here. It's greater than, so we should graph to the right. All right, we're going to do 3 more examples so that you get plenty of practice. Let's take something like this. 7 minus 2p is greater than or equal to negative 21. All right, remember our first thing we want to do is solve. So using reverse PEMDAS, use reverse PEMDAS. Is there any addition or subtraction that we need to get rid of? Yes. Right now we're doing 7 minus 2p. So you need to get rid of this 7 first. We don't want to get rid of this 2p first. Now remember, you need to ask yourself, what is the sign in front of that 7? I'm going to use this to cover it up. In front of that 7, there's a nothing. So we're going to assume that this is a positive 7 right here. How do I undo a positive 7? I subtract 7. 7 minus 7 is 0. This cancels. I'm going to bring down a negative 2p, copy down my inequality sign, and a negative 21 minus 7 is negative 28. Okay, now I still need to get p alone. What's happening between negative 2 and p? They're being multiplied by each other. How do I undo multiplication? I divide. So I'm going to divide both sides by negative 2. Now, these 2's cancel out. I'm left with p. I divided by a negative. Remember, the rule is to flip your sign if you multiply or divide by a negative. And that's what I just did. I divided by a negative 2. So I need to flip my sign. Instead of a greater than, I'm going to have a less than or equal to. Negative 28 divided by a negative 2 gives me a positive 14. So my inequality is P is less than or equal to 14. Go ahead and try to graph this one on your own. When you're ready, press play, and I will show you the answer. We should have had a closed dot at 14. It is a less than, so we should shade to the left. Let's try 2 more examples. Alright, let's take this one. N minus 6 over negative 3 is greater than or equal to negative 2. Okay, now this is interesting because we have this huge fraction over here. And we've talked about this kind of problem before because in general you want to use reverse GEMDAS to solve for a variable. But this is the one exception. When you have an entire expression like n minus 6 over a fraction, you have to get rid of this first. So how do I undo divide by negative 3? I'm going to multiply by negative 3. These cancel out, and I'm left with, oh, I forgot to show my line, n minus 6. Now, I hope that all of you saw this. We just multiplied by a negative. Remember the rule. If you multiply or divide by a negative, you flip the inequality. I multiplied by a negative 3. So instead of a greater than, I'm going to have a less than or equal to. And negative 2 times a negative 3 is a positive 6. Now I still got to solve for n. N is still being subtracted. 6 is still being subtracted from n. So how do I undo minus 6? I add 6 to both sides. These cancel out. And I'm left with n is less than or equal to 6 plus 6 is 12. Notice, this didn't flip the sign because this is just adding or subtracting. Those don't flip the signs. You only flip when you are multiplying by a negative or dividing by a negative. So my inequality is n is less than or equal to 12. Go ahead and try to graph this one on your own. You should have put a closed dot at 12. Is a less than, so we should shade to the left. I'm going to do one more example. Alright, let's try this one. We have a negative 46 is less than or equal to negative 4 minus 7n. Draw your line down your equal sign. The first thing we need to do is isolate our variables. So I'm going to use a reverse GEMDAS. And ask myself, do I see any addition or subtraction I can get rid of? I do see that this is saying negative 4 minus 7n. Now, I don't want to get rid of this first because I can't separate this unless I use multiplication or division. What I can get rid of, though, is this negative 4. How do I undo a negative 4? I add 4 to both sides. Negative 46 plus a positive 4 gives me a negative 42. I'm going to bring down my inequality sign, less than or equal to. These cancel. I need to bring down a negative 7n. Alright, now, I still need to get n by itself. So I'm going to ask myself, what's happening right now between negative 7 and n? This is saying negative 7 times n. How do you undo negative 7 times n? You divide by negative 7. Negative 42 divided by a negative 7 is a positive 6. Now, you'll notice, look here, we divided by a negative. We divided by a negative. Because I divided by a negative, I need to flip my sign. So I need to flip my sign. And I have that 6 is greater than or equal to, these cancel, n. Now before I graph this, I need to rewrite it so that the n is on the left. So n is less than or equal to 6, which means the same thing, right? 6 is greater than or equal to n, or, so the 6 is going to be bigger than n, or n is going to be less than 6. Go ahead and try to graph this one on your own. You should have put a closed dot at 6, and it is a less than, so you should have graphed to the left. Alright, now it's time for some practice. I want you to try these 4 practice problems. Pause the video, try the practice problems, and then press play to see the correct work. Alright, here are the answers to numbers 1 and 2. I want to do numbers 3 and 4 with you on here because it's a little bit tricky. Let's talk about this one real quick. We have negative 2 is greater than n over 9. Now, in order to get n alone, I have to undo divide by 9, so I'm going to multiply both sides by 9. Now, a common mistake that a lot of students make is they think, oh, I'm multiplying negative 2 times 9, so I have to flip the sign. No, you're dividing by a positive 9. I'm sorry, you're multiplying by a positive 9. You do not need to flip the signs. So this is negative 2 is greater than, I'm sorry, I forgot to multiply those. This is 9 times negative 2. 9 times negative 2 is negative 18, is greater than, these 9's cancel out, and I'm left with n. Now, in order to graph that, we need to rewrite it so that the n comes first. So I'm going to have n is less than negative 18. You need to draw an open circle at negative 18, and it's a less than, so we need a shade to the left. Alright, let's do this last one. I have negative 9k is greater than 108. To get k by itself, I need to divide by negative 9. Notice right now you are dividing by a negative. So this is k is, because I divided by a negative 9, I need to flip my sign. K is less than 108 divided by negative 9. And 108 divided by negative 9 is a negative 112. So I'm going to draw an open circle at 112, and I'm going to shade anything that is less than. Alright, now I want you to do practice problem set 2. Go ahead and pause the video, try these problems, and then when you're ready, press play to see the answers. Alright, here are your answers to the practice set 2. Let's talk about a couple of the different answers. This one, you divided by a negative 6 at the end, so you had to flip your sign. This one you divided, but you divided by a positive, so you did not flip your sign. This one, you ended up multiplying by a positive. You did not flip your sign. Even though this was negative, you were multiplying by a positive. And then this last one, you were dividing by a positive, so you did not flip your sign, but you had to rewrite it in order to graph it. Write down any questions that you might have and be sure to bring them in, and we will talk about and do some more practice during class.